So basically, we're just talking about arithmetic sequences. First of all, what is a sequence? Asia. Okay. Patrick. It's numbers in a row, right? So we can have a sequence of numbers, are just numbers that kind of follow each other in a pattern typically. Yes.
So like 2, 4, 6, 8, something.
Yeah. So let's do this one. Let's go 3, 5. Now this is a sequence. Okay. Now first of all, the goal here is, obviously to figure out how that sequence is made, be able to describe that sequence. Okay. Now, what's one way you could describe this sequence? Patrick?
Going up by times 3.
So you're timesing each one by 3?
Yeah.
So 3 times 3 is 5?
Oh, no. It's like multiples of 3. No.
You're adding 2 each time?
You're adding 2 each time, so add 2.
Aren't you adding 3 on that pattern?
Well, you're going from here to here.
Well, not 3, but...
Each time here, you're adding 2. Okay? So that's one way you can describe that. Now, here's the thing about sequences, and this is arithmetic sequences. In arithmetic sequences, you're adding the same number each time. That's what makes that arithmetic, is because you're adding 2 each time. Now, if I were to describe this,
Those are odd.
they're also odd numbers. To describe this, I think the easiest way is to think about 2 things. Where did you start? You start at 3. And, well, what does a dot, dot, dot mean?
It means it keeps going on.
It goes on forever, so really there's no ending to this. But if you think about where did you start and what are you adding each time, you can come up with a sequence, right? So I don't know, let's just make up our own sequence. Sheldon, give me a number you want to start at. It doesn't matter.
10.
10, okay. And Tyler, give me a number to add each time. 4. Okay, so we can have this sequence, and we can keep on writing numbers to the sequence, and we can go on forever. But the whole idea here is we're starting at a spot, and we're adding a number each time. Now, can I have it? And these are both arithmetic sequences. Can I subtract a number each time?
Yes. Yeah.
Because what is subtraction as far as adding goes?
Opposite. Going opposite.
It's opposite. So we could actually start at, say, 7, and add a -3 each time. So now it's actually subtracting, but we're just adding a -3, adding a -3, adding a -3. So what we're adding here is, again, a -3. So we're adding a -3, and we started at 7. Patrick?
Miss McGrath's, she had like fractions and stuff.
Yeah, we could work with fractions, and that's kind of help you practice with adding fractions. My goal right now is just to get you a basic idea of what an arithmetic sequence is and kind of what the questions are asking. Okay, let's move on to, let's go to another example here. Okay, first actually let's look at what we've been doing here. What do we end up adding each time here?
4.
So we're adding 4 each time. Now, what these numbers are called, the number that you add each time, those are called the little lines here. That's called the common difference. Because realistically, what they all have in common is that your difference between the numbers is the same. So that's called a common difference. And we use D to represent the common difference. Okay? So that's that's another idea regarding arithmetic sequences. Asia, go ahead and give me a number to start at here. Doesn't matter to me. 22. Okay. And Cody, give me a number for my D, my common difference. -2. Okay. So if I'm going, my common difference is -2. I start at 22. Okay. What would my next number be? My next term? 18. And then my next term?
16.
And then my next term?
14.
And we're going to go ahead and stop right there and just say ... It goes on for forever. Okay. Each one of these numbers is called a term. So these are all terms. All right. And this number here is the value. So the value of the first term is 22. What's the value of the fourth term? 16. What's the value of the second term? 20. What's the value of the third term?
Aren't those like the A1s?
What's the value of the sixth term? 12 would be the value of the sixth term. So there are values of terms we don't have up here, but that's the idea. So we have term values and term numbers. Now exactly what Patrick said is he goes, aren't there those the A1s and that sort of thing? Yeah. So each term, in an arithmetic sequence, we usually use the term A. Okay, A is usually our term we're going to use for arithmetic sequences. So this one right here, we call A sub 1. It's the first term. A sub 2, it's our second term. So when we look at these terms, we use that A sub number to show the term number. So how we write this is A sub 5 equals 14. One of the big obstacles in looking at arithmetic sequences are always, I shouldn't say always, but a lot of it is what are they asking? What are they asking me? So let me give you an example of a problem here. Let's say they say that they want you to find first 5 terms, okay, in an arithmetic sequence where A sub 3 equals, and we're just going to make this up. Jordan, give me a number. 17. And A sub 5 equals 23. So this is how they might ask a question. They're going to tell you it's an arithmetic sequence. A sub 3, the third term is 17. The fifth term is 23. Okay, well, we want the first 5 terms. So we already have 2 of them. So we want 1, 2, 3, 4, 5. That's what they're asking. Now the third term is 17. And the fifth term is 23. So basically that's all we're doing. I mean, we've done stuff like this before, it just didn't have words to describe and notation to describe that. So how are we going to figure out what that is? What do you think, Patrick?
I think it's plus 7.
Plus 7.
I'm not sure.
So if I add 7 here, plus 7, that is 24. Uh-oh, that won't work. So I add another 7, I don't get 23. It goes up by 3. How'd you do that? So what Anthony's saying here is that we're going to add 3 here.
Does it ever go up by
The first number is 11.
Let's check that. We add 3, we get what?
What does this have to do with the
20. This is a sequence. So we add another 3. Okay. And then, so what's the next number before that? Minus 3, so we get 14. And the number before that? 11, you have the first 5. Okay. So, I mean, you could have just guessed here to get that it's a plus 3, but one of the easier ways to do it is just to go, how far is it from 17 to 23? How far is it directly from 17 to 23? 6. That's a plus 6, but I'm doing 2 jumps here. I'm doing 1 jump and 2 jumps. So 2 jumps that covers 6 would be a jump of 3 apiece. Make sense? Okay, so the question here that was asked was to find the 10th term of this sequence. So for me, I usually actually go ahead and draw these little boxes. So that would be 6th term, 7, 8, 9, 10. So my goal is to find this term. I want to find the 10th term. We'll call it 8 sub 10. Now, there's a few of the tough things here. First of all, there's a lot of jumps to get to 10. Second of all, what drives everybody nuts are the fractions. So with fractions, and in this arithmetic sequence, you're going to add the same thing each time. When you add fractions, what do you usually need?
Common denominator.
Common denominator. So
5 each time.
these don't have common denominator. So what I would probably do is change 4 to a fraction with a denominator of 3. So if I can change 4 here,
4 over 1.
it'd be 4 over 1. Yeah, then you can multiply top and bottom by 3, and you get
12. 12 over 3.
12 over 3.
Or you could start from 2 thirds and then add it to 7.
So yeah, so you can start thinking about this. This guarantees now we can see the jump here. We go from 2 to 7 thirds.
And 3 goes in the
So that's 5 thirds we're adding. And then here we're adding to get from 7 thirds to 12 thirds, we're adding another 5 thirds.
12 thirds.
12 thirds is the same as 4. And then add another 5 thirds. And that gives us a 17 thirds.
22 over 3.
So the next one would be 22 over 3.
And the next one's 27 over 3. Which would be, I think, 9.
Right, 27 over 3, which is 9. And then another 5 thirds would be a 32 over 3.
Yeah.
Another 5 thirds is a 37 over 3. And another 5 thirds would be a 42 over 3, which is
10.
not 10.
Not 10.
42 divided by 3 would be,
Oh,
what would it be?
I think that's 13.
7, 8.
Well, I thought we were trying to get to
Be 16, 15, 14. It'd be 14. 42 divided by 3 is 14.
put the ace. Oh.
So that's the answer for the 10th term.
30.
Okay, now, one thing, let's see. 1, 2, 3, 4, 5, 6. Now, we made 6 jumps to get from 4 to this answer. So another way you could have done it is, well, there's 6 jumps, and you're adding 5 thirds each time. 6 times 5 thirds is 30 thirds, which is 10. We could do 4 plus 10. That will give us 14 also. Another way to do it.